Hi, Geo kids. So, another 4 weeks of this. And it may be longer, but another 4 weeks. I think I'm starting to lose it. I had to put on makeup today. I'm starting to lose it. Anyone else starting to lose it? Alright, so we're here. We're on day 5 of your notes. Alright, day 5.
Front door.
That's my alarm system. The front door's open, guys. Don't worry. So, Unit 4, day 5. You know what we're going to learn about today? We're going to learn about corollaries to inscribed angles. Now, Miss Bounty asked me, she said, how do you pronounce this word? And I said, corollary. 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 And she tried to say it, but I think my Jersey accent throws her off slightly. So she repeated it and she said, corollary. I said, yeah, exactly like that, corollary. So I'm really sorry if y'all just do this in a Jersey accent for the rest of your life and you have a career where you have to talk about corollaries and you say it with a Jersey accent. My bad, blame it on me. Today is also Patriot Pride Day. Did you know that? Yes. Tweet. Add these hashtags. I don't know where I'm putting them, but do that. And maybe they'll tweet it out. I'll tweet it out. Send it to me. Send it to me in Google Classroom or email it to me. I'll tweet it for you. But it's Patriot Pride Day. All right. So let's go. So today, you got to figure out what a corollary is, right? Corollary is this. So you have these theorems. We've talked about theorems in Geo the whole entire time. Theorems are like things that are true. So like, we definitely know that a squared plus b squared equals c squared in a right triangle, right? A leg squared plus a leg squared equals the hypotenuse squared. And then, what if you had other things that you could prove from that original statement, that original theorem? That's what a corollary is. That's it. So like, last time, day 4, we talked about what was an inscribed angle. So, an inscribed angle, oh yeah, sorry, if I look weird, I can't move my whole entire right side. I don't know what's going on with my shoulder, but it's a hot mess right now. You know what I think's going on with it? The fact that my head's down like this all day because I'm on my phone doing nothing. Okay, so remember an inscribed angle has a vertex on the circle and then it has 2 chords. So like this guy right here is an inscribed angle. So, inscribed angle, we're good. All these corollaries come from what we know about inscribed angles. It's so much fun. You ready? I'm ready. Let's go. All right. So, first corollary. An inscribed angle with an blank of a blank or inscribed angle on a blank has a measurement of blank. What does that even mean? What are the blanks? Let me tell you. At this point, do the people that live with you think I'm a whack job? I'm just wondering. Like, are your parents or your guardians or like, they're like, you had to deal with her every day? So sad. All right. So an inscribed angle with an intercepted arc. With an intercepted arc of a semicircle. Remember that. Half a circle. Or an inscribed angle on a diameter has a measurement of, all right, so, see, I don't like just giving it to you. This is like, if we were in class, I would give you some like exploring activity. I hate this. All right, so an inscribed angle with an intercepted arc of a semicircle, which means this. So I have, my semicircle is half the circle, right? So let's color in half. Let's color in half of that. So an inscribed angle would be something like boop, boop, like that. Or inscribed angle on a diameter. So if this is a semicircle, then we know that this line that connects these 2 chords is going to be your diameter. It's going to go through the center, right? So that's going through the center. this is 180 degrees right here, right? Because it's a semicircle, which means the inscribed angle right here has to be how much of that? What was that? Anyone? Anyone? Geo-Unit, you got this one? Oh my gosh, Geo-Unit, you're so smart. If this is 180 degrees, this has to be half because that's what we learned last class. So if it's half, this is going to be 90 degrees. So that means it's going to be a right angle. Crazy. So if it's inscribed on a diameter or if it's inscribed on a semicircle, we know automatically this bad boy right here, 90 degrees. Oh my gosh. And then what does that lead into? If it's 90 degrees, we could use what? Good old Pythagoras and his theorem. It could have been his theorem. Remember, we talked about that. He had a colt. It could have been Henry's theorem, but Pythagoras was the leader, and he was like, hey, guess what? That's my theorem now. Let's go. Next one. So at this point, I might pause it. I might time out. Pause it, and then there's this GeoGebra link that is in like the activities for this assignment. I would go to that right now because it's really cool because you can like pull the X's around and you can see that like no matter where you put those chords, if they're inscribed on a diameter or on the semicircle, you still have that 180 degrees and the 90 degrees. So it's a pretty cool little like GeoGebra thing. So if you want to like pause it right now, go see that, then come back. All right. Other thing. I braved Giant yesterday. Oh yeah. Cheez-Its. My favorite snack ever. Not the toasted kind, not the snaps. Regular Cheez-Its. Sold out. I understand toilet paper. I understand detergent. Mom's trying to get caught up on their laundry. Dad's trying to get caught up on their laundry. But Cheez-Its? Why? All right. Maybe that's why I'm in a bad mood today. All right, let's go. Hi, Jake. Oh, all right. You're going to learn? Sweet. All right. So it says at circle S on the right, what arc is the intercepted arc for C? All right. So in this note sheet, what arc is the intercepted arc for C? So if here is C, here are my two chords, right? Which means that this one right here is my intercepted arc. So the answer for that part A would be A, B, with that arc symbol over top. B, what kind of arc is it? So what is it? Is it a minor arc? Is it a major arc? Or is it a semicircle? I feel like all of you at this point should know that it is a semicircle.
I was thinking something.
That's what you were thinking?
Oh, can I tell you something?
What?
So if you look on this cheek of Jake.
This cheek of Jake?
This one.
Okay.
I kissed him, now there's lip gloss.
You
There's
kissed
lip gloss.
Jake on his cheek, and now there's lip gloss.
Yeah.
I don't see it.
It's right there.
Jake, what'd they do to you? I
I
don't
can't-
know, I'm old. All right. There you go, guys. Teaching from home. All right. So what is its degree measure? So if we have an arc, we know it has to be a 180 degree if it's a semicircle, if it's all my diameter. So what is the measure of angle C then? So again, here's my inscribed angle. If this is 180 degrees, that means this guy is half of it. So it is 90. Good, Nick. So we have 90 degrees, which means I have a right triangle. So if BC is 5, BC is 5 units, and we have that AC is 12 meters. I'm assuming that this is 5 meters, if the other one is. Then what is the length of AB? So some of you automatically are calling out right now. I feel it. You automatically know that AB is this amount because you know this Pythagorean triple. Great job. So if you didn't know that, we then have to do Pythagorean theorem. So we would do 5 squared plus plus 12 squared equals c squared. 25 plus 144 equals c squared. 169 equals c squared. Square root. And I have 13 equals c. Of course, it would be plus or minus 13, but it's a length, so we're going to get rid of that minus, just that positive 13 meters. And then I'm like, does it make sense? Is my hypotenuse bigger than my 2 legs? Yes, it makes sense. All right, next one. All right, my loves, here we go. This problem, we have to find the measure of angle Q. So I'm going to put a little question mark over there. Measure of angle Q. And we have one numerical piece of information. We're given that this arc right here, PQ, is 80 degrees. So a couple different ways we could find the measure of angle Q. It's really up to you. I have done it multiple ways, and then like a kid will be like, oh, absolutely not. It's this way. And I'm like, oh, okay, fine. Again, no wrong way. As long as you get to the answer, no wrong way. Right. What would you do? 5-second wait time. Go. 1, 2, 3, 4, 5. You have an answer? Maybe? A plan of action? All right. Nick, do you have a plan of action? All right, go.
Well, not really. But I know.
You know some pieces of information. Okay, go.
So I would divide 80 by 2.
Okay.
To get angle P and Q.
Okay.
Which would be 40
Yep.
degrees.
So since this is 80, half for inscribed angle would give me 40. Okay, go.
I don't know what else.
Don't know what else. All right. So while you were out bike riding, we learned that if you have an inscribed angle that's on a diameter, we know it's a diameter because it's going through the center, then it's going to automatically be a right angle, right? Or square angle, right angle, right? Because this would be 180 degrees, so same theory, right? So then if this is 90, this is 40. How many degrees are in a triangle total?
360.
No.
Sorry, 180.
Yep.
So you would add 90 to 40, which would be 130.
Yep.
And then subtract from
180,
180,
which gives you
50.
Yep. Anybody do it different. So I definitely think that's a great way to do it. I think that's the way you're supposed to do it. Here are some other ways that kids did. So they know that this is 180 degrees because it's a semicircle. 360 total. So if this is 260, that means this has to be 100, this arc right here. So then that would be half, which would be 50. Does that make sense? But seeing as how we just learned about inscribed angles on a diameter or on a semicircle, that makes the most sense to use what we just did. All right. How about you work on the next problem? You have to find the measure of angle D, so not just the variable. Don't pick A. So we're setting up equations using that algebra. All right, go. All right, love bugs. You should have gotten 22 degrees. 8 would have been your x. And then you substitute in, you get 22. How'd you do it? So, I know that if DE is my diameter, why do I know it's my diameter? It's cutting through that center point G. If that is my diameter, then I know this angle right here, 90
degrees.
So, if it's me, I'm not going to be like 2x plus 6 plus 90 plus 8x plus 4. I'm just going to say, all right, get rid of that 90, so I'm left with 90. Right? Did you do that, or did you set all three equal to 180? Either way, not wrong, just different. So we have 2x plus 6 plus 8x plus 4 equals 90.
Hey, Jake.
I combine my like terms. So I have 10x
6.
plus 10, because it's 6 and 4,
Oh, yeah, so you
equals 90. Take away that 10. I have 10x equals 80.
Divide 80 by 10.
Yep. And I get that x is equal to 8. Oh, if it was multiple choice, choice A, 8.
No.
And how many people would pick that? Wrong! We gotta go to angle D. And we have to substitute in 2 times 8 plus 6 gives me 22. Sorry, y'all. I hope your dog doesn't go nuts when they hear my dog. Does that happen? Jake,
Jake.
for the love of everything. Shh.
He's barking at Anna.
He's losing it in his old age. He's 13.
Oh no, he's barking at a squirrel.
Okay,
So Anna chases the squirrel away.
even better. All right. Could you come up with like another one? So if you were the test maker, right? If I were the test maker, I know what I would do. Anyone?
Angle of
Michael?
E.
Michael Autry? You out there? Did you come up with something? What'd you say, Nick?
Angle of E.
That's right. I would also do, what's 8 times 8? 64 plus 4 gives me 68 degrees. So did you substitute it in for the wrong one?
Jake.
Or D could be maybe the fact that you just automatically are like, oh, 90 degrees. That's what they're trying to get to me. So I had to come up with 90 degrees down here. All right. Let's do the back. Let's learn about inscribed quadrilaterals. All right. You on the back of your note sheet? Let's go. Another corollary that you need to know. This one is a little special. It's about inscribed quadrilaterals. Another word for inscribed quadrilateral is a cyclic quadrilateral. It's not sickly though. It don't got the corones. It's just inscribed. You ready? So, before we fill in this, I want you to look at the picture. Okay, you see the picture there? So we have quadrilateral PQRS. So in quadrilateral PQRS, I want you to think. All right, so here's angle P right here, right? So angle P has these two chords. And here is the arc that it has. Okay? So we know that angle P is going to be half of this arc, right? That's what we learned about inscribed angles. And we also know then that this angle that's opposite, right? Angle R, this one right here. So if this is angle R and it's opposite angle P, right? These guys are across from each other. And we have this one, it's going to cover the rest of the circle. Would you agree with me there?
Yeah.
Yeah. So we would have this purple arc, and this purple arc covers from arc SRQ, and then this blue arc is SPQ. So it covers the whole entire circle. So if it's covering that whole entire circle, these two together
Equal 360.
so the two arcs equal 360,
Yeah.
but inscribed angles are half of it, right? So angle R would be half of the blue, and angle P would be half of the purple. But if the whole thing is 360, then those angles together
Wait, they'd be half
of,
360.
which is,
The whole circle.
what number is half of 360? Like literally, what is half of 360? What's 360 divided by 2?
180.
Yeah. They did not teach me this at LaSalle University. They didn't. They didn't say, hey, guess what? Pandemic breaks out. You're home with 2 kids. How do you teach like this? Didn't prepare. Now, so what Dominic just said is if these two arcs together are going to give me 360, then these two angles together have to be 180 because they're half of that, right? So opposite angles. So if a quadrilateral is, oh my God, my neck, inscribed in a circle, then the opposite angles are, so we need that word for adding up to 180 degrees, and that would be supplementary. Thank you, Ann. Did you sing that with me?
Yeah.
You're so good. So they're going to add up to 180 degrees. So if angle P plus angle R equals 180 degrees, what do you think is true about angle S plus angle Q?
They're equal to 180 degrees.
Very good. And then check it out. Doesn't that make sense too? Because if these two equal 180 and these two equal 180, then all four together would have to equal 360. And that's what quadrilaterals have to add up to. All right. So there we go. That's the other corollary. Now what? Now what do we do? So we have just two examples here. That's it. So let's look at that first one. We have to figure out x and y. So we have to set up an equation. Here is where most kids go wrong. And I guarantee you know where most kids go wrong. So far, we've been like, hey, check this out. These two segments are equal to each other. These two are equal to each other. This is just half. And then all of a sudden, now we're adding things up to 180. I'm going to tell you right now. Use common sense. Please use logical thinking. These two are not equal to each other. These two are not equal to each other. That's what most kids will do. So if you're looking at that first example, they'll say that 2y equals 4y. 1, not possible. But 2, just think about that logically. Okay? The other thing is too, I know you're not supposed to look at the picture because all figures aren't drawn to scale and all that wonderful jazz. But pay attention to the angles themselves, right? Do they look equal to each other? That's like all else fails. All right, go. Set up some equations, solve. Let's go. Let's work on the y's first. So we have these two. I know it is an inscribed quadrilateral. I have those two that are opposite from each other. I don't set them equal, but I do say that they add up to 180 degrees because they are supplementary. So 2y plus 4y equals 180 degrees. I have like terms here, so I could add them together. So I have 6y equals 180, divide by 6.
30.
And I'm left with y equals 30 degrees. Do I have to solve for any angles? Or am I just solving for y? Always check. I'm just solving for y, so I am all done. Next one, I have 2x plus 3 plus 3x plus 7 equals 180 degrees. Don't set them equal. I will guarantee you that part of a multiple choice would be what the answer would be if you set them equal to each other. I combine like terms. And I have 5x plus 10 equals 180. 5x equals 170. So that means x is going to be equal to 34. And I'm just solving for x. All right. That next one looks a little bit tricky. What are you trying to find? Are you trying to find the measure of an arc? Are you trying to find an angle measurement? Are you trying to find an x value? What are you trying to find? Figure that out first. Then solve. Go. All right, guys. So we're given this picture. I'm given two expressions. And I have to solve for FGH. So the measure of FGH. So I typically highlight whatever I'm trying to find. So at the end, I check myself before I wreck myself. So, I can also see that angle A right here, is the inscribed angle on that arc. So if I can figure out that angle, you see how I'm working backwards? It's like reverse engineering. Have you ever seen that Phineas and Ferb episode where they reverse engineer it? So we have FGH. If I can figure out angle A, I know that that's twice it. In order to figure out angle A, I need to figure out what X is. And in order to figure out what X is, I can set up an equation with those two. Working backwards.
Can I say the equation?
Yes.
Okay.
Hold on. Do you guys know the equation? I'll give you 3 seconds. 1, 2, 3. If you set them equal to each other. All right, go, Nick.
So because
Just tell me. Go.
okay, 21x minus 2 plus 38x
Yep.
plus 5
Yep, and tell me why. All right, go ahead. Sorry, what are they equaling?
equals 180.
Yep. All right, go. While I'm writing this out, you tell me why that works.
Okay. So because the A is the inscribed angle for arc FGH. You could also do arc FAH, and then G would be the inscribed angle. And then you know that they would be supplementary because the angle G and A, because the arcs cover, like, the inscribed arc cover the whole thing.
Nice.
Whole circle.
Good. All right, so choice A, we know is going to be our X value. All right, what else you thinking? Now what do we do?
So now you can find angle A
Yep.
by subbing in X, and it would be 38 times 3 plus 5 equals
119.
119.
So this guy is 119.
Yeah, because 100.
Are we done?
No.
No, but we do know that answer choice B is going to be 119.
So then you would, because it's the inscribed angle, it's half of the arc.
Yep.
So the arc, you would have to multiply 119
Yep.
by 2.
Yep.
To get 238.
Nice job.
I'm gonna go check on it.
Okay, so that means choice C would be 238. Now, what would choice D be? Or E? I would say that setting these equal to each other, 21x minus 2 equals 30x plus 5, because kids make that mistake all the time, most common. So what would your x value be for there? Substituting your that bad x value in for A, and then doubling it to get that arc. So did you use that wrong x value throughout the whole entire time? That could definitely be an answer. All right, so Miss Bounty set up a Google form for you. I also gave you guys an activity to do. It's a partner activity, so you have that whole column A, column B. Now, if you really want to annoy your parents or guardian, feel free to get them involved. But if you don't want to annoy them, maybe they're a little on edge today, okay? Giant didn't have Cheez-Its. Then you can talk with somebody from the class. One person could be partner A, one person could be partner B. And then you match up your answers. So, like for question 1, partner A's answer might be 30 degrees. Partner B's answer might be 30 degrees. You'll have different problems, but you should get the exact same answer, right? So if you both get the same answer, chances are you're both correct. I've also attached the answer key onto there so you can check to make sure that you're correct. Sound good? All right. Again, we're going to keep going like this. Knowing that later on, can you stop moving? This kid moves all day long. All day long. It's like he's got ADD. I don't know how his teacher deals. I don't get it. Miss Chisholm, are you out there? How do you deal?
She doesn't.
She doesn't? What does she do? Tell you to knock it off?
No, she can't see me.
Oh my God. Send Jesus. All right. Anyway, seriously, you gotta stop. You gotta stop moving. I can't concentrate. I have ADD too. All right. So ACPS is gonna make us do a little bit of a different format. We're gonna have like some office hours, which is pretty cool. We're gonna do that through Google Meet. I haven't used that yet, so we're gonna definitely be like learning as we go and figuring this out together. But I promise you, we're gonna get you through all the material that you will need for SATs and anything else, so you are not at a loss and like, 30 years down the road, you're like, I really needed to know this theorem about circles, but I couldn't do it.